Write down the formula. F equals MA.
Is it 10.9?
It's still 10.9, part 2. 10.9 part 1 was just taking derivatives and integrals. It's called velocity and acceleration. And now we will have some motion in space. Particular example as force, Newton's second law of motion. It's a force. You can find the force. May the force be with you, by the way. You can find the force acting on an object. A vector version of this law, you don't have to write this down, all of this, just write down the formula. That's the only thing you need to know. I'm kind of thinking to give you this formula on a test. So the coordinator did not put it there, but then I realized if you don't remember this formula, you will fail with like a very expensive problem. So I feel like why not to put it there? So F equals MA. Kind of easy to memorize unless you zone out, and that's when I'm afraid it's just too expensive to fail. So I'm thinking to put at least this one there. The vector version of this law is basically says a force F acts on an object of mass M producing an acceleration A. So a force, me pulling this chair. Chair is heavy, but with wheels, and then it accelerates. See? So that's makes sense. Memorize this. And then we're gonna do, since it involves acceleration, guess what we're gonna do? We'll be integrating and differentiating lots of things. Example 1. This is a very good exam problem. Suppose a particle has a mass m, it has a given position. Find the force acting on the particle as well as the magnitude. So force now has a direction. Well, that makes sense. I'm pulling here, not here. Okay, so direction matters. But then force also has a strength. Did I pull it just a little bit? Okay, so that will be magnitude. So that makes sense. All of this, I think, makes sense. I feel like if I understand physics, you definitely should understand physics, because that is not my specialty. So many people in this class know physics much better than me. So let's do this example. What are we doing? Integrating or differentiating? So we have position, we need to find acceleration. Okay, I guess step 1, where is acceleration? Why are we going to mention that? Because they asked us to find F, and F has a formula, MA. F equals MA. M is 4, that is good, it's given. A is not given. So 4, well, let me put it in black. 4 times the vector A. So now we know we have position, we need to get acceleration. Integrating or differentiating? Differentiating. R prime gives you A. R is your position, which used to be whatever distance, D or S. Usually it's S in the calculus 1. Physical interpretation, the particle is moving on a circle of radius 3 with the angular speed 2, and we need to find the force acting on it. What the heck? Where did we see the circle? This is a circle. 3 cosine 2t and 3 sine 2t. 3 cosine squared plus 3 sine squared gives you x squared plus y squared equals 3 squared. So it looks like that. Just catch the picture. So very interesting. The particle is moving on a circle, and we have a force. We need to find the force that's acting on it. And it's called an angular speed because the circle has a radius 2, angular radius 3, angular speed is 2, that kind of stuff. Angular speed comes from this angle. Very interesting. So you don't have to write this down in interpretation unless you're a physics major, then you should do that because that's your thing. So, but that's a sketch. I'm just curious about the sketch. And then after this, I'm just curious to solve the damn problem because I want to point some example. So I'm always very clear about it. All of this is very interesting and amazing until we got into exam part. Now I just want to know how to finish this. Am I right? Yes. Like very practical here. We all want to learn and be amazing and stuff, but then it comes to the test, you just need to do the test. Like it's nothing else. Just the goal number 1, do the test. Solution. Step 1, know the formula. Lots of formulas in this class. That's very unfortunate, but it is what it is. Everyone was supposed to repeat it. Let's try again. It is what it is. See, good job. Everyone know this. Equals m times r prime prime. M is 4. Can you stop jumping? You're fine. What is this, like panicking mode? Come on, you can do it. Well, you can write right down by yourself. Find r prime. What is r prime? While I'm waiting for this cable. I think it's a classroom cable is glitching. Unfortunately. We are number 1 in innovation, and that is why there's always something glitching.
Is that USB Type-C dongle?
But yes, but I think it's their cable, though, not my cable. But maybe it's. Oh, you see, you needed to open it earlier. Thank you. You brought good luck. So let's find the first derivative. R prime is, so step 2, let's find m. First derivative, then second derivative. There's no way to skip, actually. Only repetitive functions you can skip derivatives and guess or calculate some 16th derivatives. In general, you cannot. You have to just do one by one. And that's where, so let me ask you if you remember these small mistakes or not. 3 cosine 2t gives you minus 3 sine 2t. Yes or no? Times 2, so 6, right? That's nice. Then don't forget also plus or minus, which one is which. 3 sine 2t gives you 2 cosine 2t. Yes or no? Should be 4, right? Correct? No, 6. Still 6. So this is 3 then? Yes. It was 3 times 2 is 6. So don't forget chain rule. Let's go chain rule, your favorite rule. So this is what we found. Whatever we found right now is velocity vector. So now everything has direction. So velocity used to be a function, calculus 1, acceleration is still a function, but now it's a vector function. Describes also direction now. Step 3, r prime prime. Keep going, you can do it by yourself. Minus 12 cosine 2t, comma, come after class right now if you don't remember chain rule. It would take me 5 seconds to explain it to you. So it will be nice just to tell you how to do it. Don't be afraid to admit it if you don't remember calculus 1. Most of people don't remember. Yeah, thank you. Good job. You see, I'm doing mistakes on purpose. A of t. Finally, kind of the answer follows after that. Step 4, f is ma, so it's going to be, let me write down one more time, ma, 4 times the vector we just found, times minus 12 cosine 2t, comma, minus 12 sine 2t, vector. Simplify. I don't think it's necessary, but if it's a multiple choice question, it will be simplified. So minus 48 minus 48 cosine 2t minus 48 sine 2t. That is the answer. Put it in the box. On the test, you also put everything in the box. That speeds up grading. And you want me to grade fast, so you better put everything in the box and try to write nicely. And the other thing they ask you, will find the magnitude. Okay, magnitude, or basically how strong is the force. That's magnitude. Well, it's the square root of all of this stuff. Square root, I would factor out the 48 thing, so maybe distributing it was a stupid idea after all, but whatever. 48 squared, I don't care about negative, but to be correct, I'll put it inside. And then you have cosine square plus sine square. Do you see that? Cosine square plus sine square. When they have the same angle, it gives you 1. This is 1 right away. So the answer is square root of a square root of 48. Guess what it is? 48. Do you know the units of that? Newtons. Good job. And you don't have to know that for the test. I don't ask units on the test ever. You have too many classes that do ask about it, so I feel like I don't have to. Can you do it on the test? A very nice problem. Differentiating for this example, integrating for another example we did before, where we have to go from acceleration to distance. So the force, so you remember, distance vector shows you how far the object is moving on this circle in this specific example. Velocity, how fast it is moving. And then second derivative is how fast the velocity is changing. That's acceleration, and so on. Some interesting information you don't have. Did you finish writing? Yeah. How you don't have to write this down. Let me show you this. Angular velocity. In general, angular velocity is pretty interesting thing. In physics, looks like that. As you can see, cross product is involved. This is orbital angular velocity. Of course, space science or space exploration engineers will definitely like that. Uses lots of vectors and cross products there. So let's just look through this. There was something also really cool. This one, check it out. So that's pretty cool. Diagram showing Euler frame in green. Look at that. Finally, in physics, angular velocity or rotational velocity, also known as angular frequency vector, is a vector measured of rotation rate that refers to how fast an object rotates or revolves relative to another point, how fast the angular position or orientation of an object changes with time. There are two types, orbital angular velocity and spin angular velocity. Orbit angular velocity refers to how fast the point object revolves about fixed origin. Spin angular velocity refers how fast a rigid body rotates with respect to its center of rotation and is independent of the choice of origin. That's pretty cool. So all of this, I imagine, is in a space science. They definitely do all of this over there. It's pretty cool. But also atoms, they also rotate. So it's macro science and micro science using all those formulas. Pretty cool. Angular velocity is a ratio of the total angular measurement through which a particle rotates in a given unit of time, omega. So change of angle with respect to time, that's what it is here. Change of angle with respect to time. Blah, 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 you can read, that's very interesting. Consider the Earth with rotation on its axis once every 24 hours. The angular velocity of the Earth's rotation will be this, 2 pi over 24. That's the idea. Force, this is how it looks like. And this is, I think, a pretty cool example is this. Like why people don't fall off. Well, some people do. In the entertainment parks. Because there's a centripetal acceleration and force happening. So this drags you inside, but because it's on the circle, it also drags you outside, blah, blah, blah. And of course, they checked everything before letting people in, hopefully. And that's why you don't, you see, while you're being dragged inside, right, there also speed drags you outside. Are they perpendicular? Maybe, or not. So that's actually pretty cool. That all of this is called centripetal force. When the force acts in a direction opposite to the radius. So radius is this, opposite, and that's why you don't fall, because it drags you perpendicular away. And the points towards the origin is called a centripetal force, and in this case with sines and cosines. Lots of sines and cosines and escalations, you see? So this is very known. All of those formulas are very classical, actually. Let me show you that. Basically, this is what it is. Look at that. It drags you in, so you're supposed to fall. So you're on top right now, upside down. You're supposed to fall, but it also drags you perpendicular out. So you keep basically going on a circle. Pretty cool idea. That is the idea here. And this one, physics forums. Look at that. See how it increases. Drags more or less towards the center. And the gravity, you see, it also takes it back. Pretty cool idea here. Oh, also this person, right, who is swinging some object with a given mass, also doing the same activity. Let's see here. Oh, check it out. And physics and engineers basically working on that. How to create mechanisms using this centripetal force. And this is basically how the motor is working and many other things. So that's pretty cool. If you feel excited about this, you chose your major right. I always say that. Like, if you feel that is cool, yes, physics and engineering is your thing. Projectiles is a projectile is any object that is cast, fired, flung, heaved, hurled, pitched, tossed, or thrown. Okay, that was a lot of English words. The path of a projectile is called its trajectory. Some examples are basketball that has been pitched, batted, or thrown. Okay, a bullet, the instant it exists, the barrel exits. The barrel of a gun or a rifle. A projectile is any object with an initial non-zero horizontal velocity whose acceleration is due to gravity alone. So you see the water and then drops. Trajectory of a simple projectile is a parabola. Wow, what a surprise. Let's experiment. It is parabola. It has also maximum. So usually I teach calculus 1. I threw things and we notice there's a maximum, so we learn how to find maximum. Also, the curve is increasing, decreasing, derivative is positive, negative. It's concave down, so the second derivative is negative, and so on. So that is also pretty cool. I find that this is very interesting. A particle is thrown away with initial velocity and angle, and the particle travels at a time horizontally and vertically at the same time, and there's a gravitational force. Remember your favorite number, 9.8 from calculus 2? So finally, let's just do an example from your homework. Let's do that. Let me see if there's something else left. Oh, that's all. So let me make a new video. That was a theory to make it more interesting, to motivate you to like this class and give good evaluations. Did I say it out loud? But you know, homework, that's what I need to do. I like giving people homework solutions.